Radio.
Hello everybody and welcome back to another episode on my channel. My name is Karate Mario and today we are doing another video on computational redstone. This is part 2 in this series, and today I'm going to be teaching you about logic gates, because they're probably like the second biggest thing to know from binary. So yeah, today I'm going to teach you about it. So what is a logic gate? Well, if you've ever used redstone before, chances are you've been using logic gates without even knowing. So the most common one that you probably would have been using is this OR gate. Now an OR just means that basically we will have an output whenever we have two inputs basically, and it will output when either or both of them are on. Then the next that you might have done, although it's very unlikely that you would have done this without knowing what an AND gate was, but it happens. And so an AND gate only turns on if both inputs are on. That's the only time it will be on, because here we have two torches powering. They both lead into the same line that powers another torch. So basically, so long as one of these torches is on, this torch is going to be off. Yes, so let's move on to some of the more advanced stuff. These are very basic stuff. Now, first advanced one is a NOR gate. So a NOR gate, it's still borderline easy, but it's an OR gate that is connected to an inverter, the torch being the inverter. So it will only power on when neither of these are on. That's basically how the OR gate works. And I'm gonna do it like this just so that we can keep it in a nice orderly formation. Not that that really matters, but oh well. NAND. NAND is the next one. So actually I'm going to label these. So down this end we have a OR. In here we have our AND. Then we have our NOR. And here is going to be our NAND. Now, you can probably guess what NAND is. It's the opposite of an AND. So the only time the redstone will be off is when both of the levers are flicked. So if we do something like this, it's always on. We can flick this one, we can flick this one, and it will only be off when both of them are on, pretty much. Right, so these two are sort of really easy beginner stuff. These two are starting to get a tiny bit more complex, and the next one is an XOR gate. So I'm going to build this out for you, and basically what an XOR is, when neither of them are on, none of them are on, like the light will be off, and when, I'm just going to use a torch here, so both of them are off, it's off. If one of them is on, then the torch is on, and same if the other one's on. But if both of them are on, then the lamp is off. And that's why we have the X. The X stands for exclusive. So let's write this in, XOR, and the X means exclusive, because it won't be on. Basically, it's an OR gate with an AND gate inside it that turns it off. So yeah, pretty much a NAND, I guess. So this is how an OR gate is made. It looks a bit more complicated than the rest of it, doesn't it? So this one will be off, but when both of them are on, this AND gate we have up here turns this torch on, which turns off both of these. So you can see none of them are on, it's off. one is on, it's on, and we can put the other one on, it's still on. Both of them though, and it's off. That's how an XOR gate works. And then, can you guess what the next one's going to be? You probably have XNOR. So, it's pretty much the same, exclusive NOR. So, it's the same, only we pretty much just slap an inverter on the end. Again, the inverter that we're using in redstone is a redstone torch, because that's the best form of an inverter that we have. So if I lead it over here, we have our lamp out here, so it will only be on when either neither of them are on or neither of them are off. So if we turn one on, the lamp turns off. Turn the other one on, the lamp turns off. Turn this one on, and they're both on, the lamp turns on. So they're basically the six logic gates that you can get, and they're extremely useful in any kind of computational thingies. Let's have a look over here. This is a 3-bit binary multiplier I have. If we look over here, these are all AND gates, these are XORs, these are NORs, and they all lead round, and yeah, pretty much everything in computers when using redstone, it's all gates, it's all logic gates. So that's how it works. In case you wanted to see how this works, let's just type in let's do 6 times 3. This should be 18. We got a 16-bit on and our 2-bit on. And of course, if you don't know what on earth I just put into this, then you obviously didn't watch the last video. So I'd recommend you go and check it out. We learnt about binary. But yeah, that's it for today's episode. It was a rather short one. But yes, it's just, I wanted to teach you guys this before we got into any more advanced stuff, because this is the basis of everything that there is to come. And yes, I'll see you guys in the next video. Bye bye.